Okay, folks, today we're going to be looking at climate controls. First thing we'll look at is latitude. Farther north you go, the colder it gets. Kind of a no-brainer. If you go farther south, it's going to get warmer. So, I'd like you to go to your notes. Latitude, write this down. Farther from the equator, it gets colder. There's also less moisture. Closer to the equator, gets warmer, and there's more moisture. The next one is kind of another no-brainer. Altitude, your height above sea level. The higher up you get, the colder it gets. And here's a great picture to illustrate that. Here's a nice, beautiful mountain range. Why don't you look closely in here? Notice the tops of those peaks. They've got snow on them. Must be pretty cold up there. If you go lower down, though, into this beautiful grassy meadow, no snow. Must not be as cold there. So, altitude, pretty simple. Higher equals colder. Well, here's where it starts to get a little more complicated. Oceans can actually have a big influence on an area's climate. Places that are closer to the oceans are going to have climates more like this. The seasons tend to be more mild. Summers don't get as hot. Winters don't get as cold. Remember the whole specific heat of water thing we talked about a few days ago? Water takes a long time to heat up, but when it does, it holds on to its heat for a while. So all summer, it's storing up its energy. So if you happen to live along the oceans, summers will still get pretty warm, but not as hot as they would in other locations. And then in the wintertime, the air doesn't get quite as cold. Also, this part's kind of a no-brainer. If you live closer to the ocean, you're probably going to get more rain. Now, if you go farther from the oceans, you start to see more extremes in your climate. The oceans have that moderating effect on climate. So since we're not close to the oceans, the climates aren't moderated as much. So the summers get hotter. Winters get colder. Let's go back to our notes. Distance from ocean. Write this down. Closer equals more precipitation, warmer winters, cooler summers. Farther equals less precipitation, colder winters, and hotter summers. Moving on here. The next climate control we're going to look at is called the orographic effect. It has to do with mountainous regions that happen to be next to big bodies of water. So here on the west coast of the United States, there are a lot of mountains, and the winds are typically coming out of the west. That means they're coming off the Pacific Ocean, and they bring a lot of moisture with them. Well, when they run into the mountains, they end up dumping their moisture on one side of that mountain range, and they make a wet climate. When the winds get to the other side, you end up getting a dry climate. If you could actually see this orographic effect, it might look like this. You got your moist air coming off the ocean. When it runs into those mountains, the air rises, and when it rises, it cools. When it cools to its dew point, water vapor condenses, and it makes rain. But here, I want you to notice, it's making rain only on one side of that mountain, because that's about as high as that air can rise before it can't carry its water anymore, and it dumps it on this side. The air keeps rising, though. It's drying out, and when it moves to the other side, you end up getting the very dry climate forming over here. This is what we call a rain shadow desert. We even have the orographic effect here in central New York. You know how that lake effect snow that we get in the wintertime here? Well, it's partly due to the orographic effect. We get our cold continental polar wind coming down from Canada, passes over the lake, water evaporates up into it. When that air moves back over land and it runs into Tug Hill, it's forced up. When that air is forced up, it cools. When it cools to its dew point, in this case, it makes snow. So there's our lake effect. So let's go back to our notes again. Mountains. This part is easy. For now, let's just say they can block moisture. C, orographic effects notes. If you look at the next page, you should see this diagram. How does the orographic effect work? It's all summed up here for you, so read this on your own. Here's a diagram showing you the process. There are a few things I want you to add to it though. The side of the mountain that receives the wind first, we call the windward side. Write that down. And this side gets the wet climate. When the air moves up and over to the other side, it's now much drier. This side of the mountain is called the leeward side, and it gets the dry climate. Next, we're going to look at ocean currents and how they affect climate. Quite simple, you have two main types, warm and cold. Great example of a warm ocean current is right here off the east coast of the United States. It's called the Gulf Stream. Gulf Stream is a warm ocean current because of where it's starting. These waters are actually fed from other currents that are coming off of the equator. And as you know, water has a high specific heat. So when it gains energy, it holds on to it for a long time. Long enough, in this case, for it to flow all the way up the east coast of the United States and all the way across the Atlantic Ocean. And it runs into Europe, bringing warm water with it. What happens here is it helps to moderate the climates. Places that are farther north that might otherwise be pretty cold, they're not quite as cold because of that warm water. Here on the other side of the United States, we have an example of a cold ocean current. This is called the California Current. It's coming from the waters off of Alaska. Well, it brings cold water with it, and that cold water brings cold temperatures with it, and it flows back south down the west coast of the U.S. If you've ever been swimming in the Pacific Ocean, you might know that the water is actually pretty cold there, all because of this cold ocean current. But again, this helps to moderate the climate there. Places that are that would otherwise be pretty hot aren't quite as hot. I would like you to write this down about ocean currents. They can warm or cool areas. See reference tables, page 4. And if you look at the next page in your notes, you will see this map. This is out of your reference tables. This shows you the major ocean currents around the world. It also shows you if they're warm or cold currents. You simply look in the key. Is it going to be warm or a cold current? It all depends on where it's coming from. The final climate control we're going to look at are the prevailing winds. Prevailing winds are where the winds normally come from. So on the west coast, the prevailing winds usually come out of the west and they move east. Well, the same idea where we live. The winds usually come out of the west and move towards the east. And for us in the wintertime, our prevailing winds come out of Canada. Continental polar air, that cold, dry air. The prevailing winds are also responsible for all the lake effect snow that we get here in the wintertime. The prevailing winds will bring changes in temperature depending on where they're coming from. They could also bring changes in moisture depending on where they're coming from. So let's finish up the notes here. Under prevailing winds, let's just write where the winds usually come from. Now, if you look at this page in your notes, you will see another chart from your reference tables. This is the chart showing you the major wind belts around the world and also moisture belts. What you'll see are the prevailing winds. Anywhere from 30 degrees north to 60 degrees north, the prevailing winds are generally out of the southwest. Above 60 degrees north, they're generally out of the northeast. And if you need to know the prevailing wind directions for any other latitude, you can look it up here. This is also showing you where we generally get wet climates and dry climates, depending on if the air is rising or sinking there.